Hey, I'm John Humphreys, and this is a follow-up tutorial to my first one on Maven and IntelliJ. This video will cover where artifacts are stored in Maven, how dependencies are scoped, what build plugins are and how to use them, what the effective-POM is, and what parent-POMs are and how to use them. If any of this seems new to you or you need a refresher, please look at my last video which covered the basics. So, in the interest of being complete, let's start creating a new project from the Maven Quick Start archetype, and while that's happening, we can check out a cool new HTTP library I found the other day. We'll use the library in our code after importing it from Maven, and then we'll see where the Maven dependencies were actually saved to on our computer. The project should be ready in a few moments. What you see in front of you right now is the page for unirest.io. The cool HTTP library that I referred to. We'll quickly drop in the Maven dependency tag shown on the site, and then we'll copy out their example and swap the site that it refers to for JSON placeholder, which is a useful demo RESTful web service that people provide just for providing a little fake data for examples just like this one. So I'm taking the copy dependency tag and pasting it into the dependencies section of our POM file now. The dependency will automatically be downloaded by Maven for us. So let's jump into the main class after that and copy paste in the example web service call from the website. After I do that, I'll be using Alt-Enter to automatically add the import statement for the class we used and to add the exception handling. Now, let's quickly change this code over to what we need to target the JSON placeholder website call just to get some sample data. We'll change it from a post request to a get request, remove the post content, and we'll target the body specifically. That way we can print it out to console. Now all the code is ready, except we just have to replace the URL with the one from the website example for the placeholder. So I'm just going in now and copying out the two parts of the URL, and then we'll run the code and we should see a nice result from them. And there it is. So we're successfully using this unirest HTTP library to pull data from jsonplaceholder.typeofcode.com. Now, as promised, let's see where Maven is storing the unirest library that it downloaded for us. Maven has a repository folder on your computer, which is typically in your home directory in a .m2 or .m3 directory based on your Maven version. So for me, it will be in cusersjohn.m2. Inside that directory, there can be some configuration and then a repository folder. In the repository folder, you will find directories matching all of the packages you have ever used in Maven, and the ones you've built yourself. Glancing at our HTTP library again on this website, its package was com.meshape.unirest. So let's navigate down to it and see the jar it gave us. And here it is. This is where it ended up when Maven downloaded it for us. One good thing to note here is that the version of the dependency here is 1.4.9, which does correspond to the one we had in the website. If you have 10 different versions of this used in different projects, you will see all of them listed in the package hierarchy here as we went down through the versions. Now let's move on from how artifacts are stored to what their scope can be. When you declare a dependency tag in Maven, in addition to the mandatory group ID, artifact ID, and version, you can optionally provide a scope. If we quickly glance into our POM file, we can see that JUnit was provided by the QuickStart archetype as it provides a mock unit test for the mock main class that it gave us. The JUnit dependency that it added is scoped as test. Test is just one of the 5 main dependency scopes supported by Maven. The default one is called compile. If you do not leave a scope tag, that is the one it ends up being. That means that the dependency or library is around all the time, whether you're compiling or running test or main code. Provided means that the dependency will be provided to you while running, but you want to have it around while compiling. A good example of this is using anything that happens to be provided by application servers. An application server may run your application and 15 other ones at the same time, and it has a bunch of libraries around on its class path for that. You can't provide anything that it provides. So you need it around to compile and tell your program to use functionality, but you can't provide it while running. Runtime is kind of the opposite of that. A lot of frameworks compile against something called SLF4J, for example. That is like a logging facade. The frameworks will write to SLF4J, and then at runtime, you include your own specific logging library, like log4j or logback. And the idea is that you did not keep those around at compile time, but you have them at runtime, and since they're on your class path at runtime, SLF4J will be smart enough to automatically detect them and route logs from those frameworks to your logging library. So this literally means that you're just using dependencies and you only want them around while you're running the code, not when you're compiling the code. Tests means you want to only have the dependencies around while you're compiling or running test code. And this is great for anything that's part of your test harness that you do not want to sneak into your main code. And system means that you want to point to a specific file on your local computer directly. This is used much less often. Our next subject is build plugins, and they're probably the coolest feature of Maven. Maven has numerous build phases: clean, validate, compile, test, package, and install, as we talked about in the last video. Each one can have plugins designed for it. There are a ton of plugins built for Maven already, and you will use them very frequently. Often you'll even have 3 or 4 in a small to medium-sized project. They can do pretty much anything. A few very cool examples include the Antler plugin, which can generate parsers for you based on its own domain-specific language, the Query-to-Sail plugin, which can generate database interface objects based on your database tables, various plugins that can analyze your unit test coverage on your code and make cool report websites based on that, and the Maven Shade plugin, which can do a ton of things, including making your project into a runnable jar. And that last one will be our example. So we're going to use the Maven Shade plugin to create an executable jar. That basically means that all the dependencies we need will be packaged with the jar, and the manifest file, which is held in the jar, will be told what the main class is for our jar. That way you could just run our program with java-jar. This really makes it a lot easier to deploy. You're just deploying a standalone artifact that has everything you need, so it's really a fantastic use case for a build plugin. We're going to copy this example from their website into our POM file in the build plugin sections of our POM file. And then we're going to carefully update the main class here with the one from our main, the file holding our main function. And after that, we can just hit clean and install again, and we'll see that the target results are a little different this time. We'll have 2 results. One's a shaded jar and one's a normal jar. And basically the shade plugin renames the shaded jar to the normal jar when it's done. But that's a good way to see that it's done. So we actually want the one that's highlighted right now, the normal jar. To make this a little more concrete, let's jump into a command line so you can really see what we're talking about. To run a normal Java application that isn't compiled as an executable jar, you have to use the Java command, you have to name a class path where the syntax is a little frustrating, and then you have to tell it the main class to run, all in the command line args. In this case, we could literally just type this, java-jar, and our jar file name, and you'll see it go do that whole web request that we just coded. So that's fantastic. It's got the web request library bundled in, and it can go do the actual web request from our main class just by us telling it which jar to run. This is why it's a much better way to deploy things. And you can see that the build plugin was extremely easy to use for this purpose. So now you've seen a good example of a build plugin. Remember, there are thousands of them and they can do literally anything, and they're probably the most powerful feature you'll use in Maven. So get used to them and enjoy them. Moving on, our next subject is the effective-POM. If you jump into IntelliJ and you right-click on the Solution Explorer's pom.xml file, then you can go to Maven and show effective-POM. And sorry, I know that it's running off my screen. The effective-POM is the final version of the dependencies file that Maven generates. It's a mix of the POM file that you gave it, plus information from all the dependencies that it had to download, plus a bunch of other things that are just needed to build and run your project that it likes to hide from you. A very good example of an extra piece of information you get in here right now is if you look at our com.meshshape.unitRest Java library that we're using for doing our web requests and our example code we made, you can see in here it actually has scope as compile. Whereas if we went back to our original thing, it's actually got no scope assigned to it. So this is just one example of how you can see what Maven's really doing in nitty-gritty detail terms in the effective-POM that you can't see in the normal POM. And in general, you will not need to use this on a daily basis, but it is a really good debugging tool when you have issues. And just one example of these issues would be sometimes you'll be using libraries, and you'll find that a version that you needed of the library in your project is conflicting with a version that's used by one of the libraries you already included. And it's really hard to detect problems like that until you look in here and see, hey, this dependency is in here 3 different times and I have different versions. Then you can start to play with it and solve the problems. Let's move on to our final subject, parent-POMs. Parent-POMs are Maven projects that you can derive from, much like your Java Lamborghini class might derive from a basic car class. It can be much more general than that, though. Companies often use parent projects or parent-POMs like this to ensure developers in various teams use the same basic framework and dependencies. For example, consistent logging libraries or the same version of MySQL libraries. A great example of a framework that uses parent-POMs to great advantage is Spring Boot. Spring Boot allows you to turn a simple command line program like ours into a fully fledged production-ready single jar web service. So we could, for example, trivially serve the result of our current program through a web service with really just 10 or less lines of code once we're using a Spring Boot parent projects. Let's show off the power of parent-POMs and do what we just said with Spring Boot and turn our project into a web service in the next minute and a half or so. I've pre-copied code across from the website we're staring at right now. There's just a few lines here, 2 Maven dependencies, one for the parent, one for a library, and then some sample code for starting the project. So if we jump over to our IDE here, we can see that at the top of the POM file I have added the parent reference that we got from the website. This does most of the work in pulling in the Spring dependencies and making everything available for Spring Boot and setting up various build plugins. I've then also added the other dependency they listed for the starter web project. Then if we jump into the main application, we see that I added the annotations that they recommend at the top for a controller to let us serve a web page and auto configuration to let it basically start using the Spring Boot features. And then we've just slightly changed our main function. Completely changed it actually. We pulled the logic for the main function into a controller endpoint. This means that when we go to localhost 8080 in our browser, we can actually see the results we used to see on our command line. And the main function now actually just tells it to run the Spring Boot application, which is actually a web service. So if we jump into our program and tell it to run the main function by right-clicking and hitting run, we'll actually see that it'll start starting up something a lot more complex than it did before. And this is the Spring Boot web service. It only takes a second to start up because there's not much in it, so if we jump over to our browser now and go to localhost 8080, then we can actually see what we used to see in command line from the website that we're querying in our browser. So we have a fully functioning web service thanks to using this parent-POM in the Spring Boot framework. So I have to wrap up quickly because I'm hitting the 15-minute limit. But this is just an example of a parent-POM. I know it was a lot to throw at you with Spring Boot. I do have other videos for Spring Boot on YouTube, so please visit them to understand it more. And I hope you found this whole thing useful. If you did, please subscribe to my channel and check out my other videos. I'll have more coming soon. Thanks.